Hi guys, good morning. My name is Shiva. I'm currently working as software lead architect for automated parking and autonomous applications in Germany. Today I'm going to present you how to detect lane lines as part of a self-driving car. I'll focus mainly for the beginners, considering the basic techniques. I'll make a different video for the advanced techniques. There are several steps involved in detecting the lane lines. Let us go through them one by one. Consider an image captured by a camera connected to the car on highway. Consider this image has lane lines, road, other vehicles and surrounding environment like trees, etc. Our main goal in this video is to detect and highlight the lane lines. The first step is to take an input image and convert it into the grayscale image. And the second step is to apply the Gaussian blur on it to remove the unwanted noise. One of the important parameters of the Gaussian filter is kernel size. The large kernel size means you are averaging or smoothing over large area. The outcome of the second step is the blurred image. Third step is Caney edge detection. In Caney edge detection, we need to calculate the gradient, which is rate of change of pixel value. The brightness of the pixel corresponds to the strength of the gradient at a particular point. The edges can be identified by tracing out the pixels which follow the strong gradient. Once you identify the edges, it is very easy to identify the objects based on their shape. In our case, the object is line. Caney function will take the three input parameters, input image, which is nothing but the blurred image in our case, low and high thresholds. Caney function will extract the strong edges by considering the pixels above the high threshold and rejecting the pixels below the low threshold. The pixels between the high and low thresholds are considered only if they are connected to the strong edges. The outcome of the third step is the image with edges. Now going to the fourth step, which is nothing but the region. Basically, you need to find the region of interest where you can exactly find the lane lines. Fifth step is Hopf transform, which takes an input image, which is nothing but the image with edges, scan through each point corresponding to edge, and then extract the line information. I would like to explain the basics of Hopf transform in this video, and I'll make a different video for detailed explanation of Hopf transform. Consider there is an image space and Hopf space. A line in image space is the point in Hopf space, and similarly the point in image space is the line in Hopf space. Consider there are 2 points x0, y0, x1, y1 in image space, which corresponds to the 2 lines in Hopf space which are intersecting with each other. The intersection point is nothing but the line connecting to x0, y0 and x1, y1 in image space. This is the basic principle of Hopf transform. Let us go through different parameters of Hopf transform function. Input image, which is nothing but the image with edges. Rho and theta are the distance and angular resolution of grid in Hopf space. Threshold, the minimum number of voids or intersection points which represents the line. Minimum line length is the minimum length of the line which needs to be considered in the output. Maximum distance is maximum distance between 2 lines which can be connected and considered to be one single line. Yeah, now we identify the lines, but the next step is basically step 7. Step 6 is basically to extract the left and right lines based on the slope. Example, the left lines will have the negative slope and the right lines will have the positive slope. The 7th step is to extrapolate and extract the lane line information. Now we've identified the lane lines. Plot them on the original image. That's it. We actually gone through all the steps involved in detecting the lane lines. All the above steps which I mentioned can be programmed by Python or any other high-level programming languages with the help of OpenCV library. Thank you very much.